Hey everybody, this is Alex Merced, and welcome to another episode of Gnarly Data Waves presented to you by Dremio. And today on episode 50, we're going to talk about how to optimize your analytics with Apache Iceberg, Dremio, Snowflake, and the Data Lakehouse. And essentially what we'll be talking about is just basically the way that these technologies fit together and create a better story. Um, so let's get into that. But before we get into that, of course, we got our obligatory announcements. First being that, again, we are Dremio, the unified lakehouse platform for self-service analytics. And again, basically, what Dremio provides is a nice sort of wrapper around your data lake to make it feel like a data warehouse that provides you sort of services in sort of three tiers. You have unified analytics, so being able to connect your data sources from everywhere, federate queries between those sources with that powerful SQL query engine, which is like that second tier, where it's a really fast query engine that, again, can federate those queries across different sources, that allows you to query data on-prem and in the cloud, and has some really powerful acceleration features and lakehouse management. So when you're trying to execute a lakehouse where you're trying to do more workloads on the lake with formats like Apache Iceberg, Dremio can then help manage that lakehouse by automatically optimizing tables, doing garbage cleanup, providing you versioning of that catalog so you can practice cutting edge data ops. So that way, basically, you end up having that data warehouse platform like feel, but on your data lake with all the benefits, the flexibility, the lower cost of a data lakehouse. So that's Dremio. We'll talk more about it as we go on. But again, you can deploy that on-prem or in the cloud using our different deployment options. And one of the best ways to kind of just get a little bit more hands-on, so that we can kind of see how awesome this thing is, scan that QR code right there on the left to do an exercise where you'll actually spin up Dremio on your laptop. I'll share that link a little bit later on. And then if you want to go even further and actually practice the whole end-to-end solution of taking data from a data source like a Postgres or a SQL Server or MongoDB and see the journey of that data all the way to a BI dashboard with Apache Superset using sort of like the Dremio Lakehouse patterns, scan any of these blogs to go through an exercise that'll take you through that end-to-end all on your laptop using Docker. So that way you can just get hands-on at no cost, no risk, and just kind of, play with it. But soon is going to be the Snowflake Summit. Okay, this is the annual Snowflake conference, and Dremio will be in town on June 5th. We're going to be very close to the venue, and we're going to be holding an event, Dremio and Snowflake, Iceberg-centric analytics and AI. We're going to be having a lot of lightning talks and a meetup all about just sort of like improving data lakehouse analytics. And that's going to be at the Dremio Chill Lounge, which is going to be at 221 4th Street in San Francisco, California. We'll be there all day from 9 to 5:30 p.m. Make sure to be there. If you're going to be in town for Snowflake, stop by and enjoy a few moments of chilling with us in the Chill Lounge. But with no further ado, let's get on to our featured presentation, how to optimize your analytics with Apache Iceberg, Dremio, Snowflake, and the Data Lakehouse. Okay, now, of course, we always want to establish sort of what's the problem. What's the problem with sort of modern analytics these days that we're trying to solve for? And bottom line is that we move the data a lot, and this results in lots of broken pipelines that require tedious backfilling. Okay, and again, all of these things not only are just tedious and painful as a data engineer, but they're also going to be very frustrating for end users who are getting the data late or getting inconsistent data and not being able to deliver on their SLAs. And so basically you have the frustration that the data engineers experience in delivering these sort of large layers of brittle pipelines, and the data analysts and data scientists and their frustration with, basically getting the data late or getting basically not perfect data. But you also have the cost of the business if you're a business leader, which comes in the terms of storage costs, compute processing costs to compute those queries, okay, network egress costs when you're moving that data from outside of your different types of clouds, lost productivity in the time it takes to just kind of sort of duct tape all this together, regulatory fees when PII isn't perfectly protected and things like that. You got data model drift, and there's so many different copies of the same data that it kind of drifts away from your different data models, resulting in, data model drift and the cost of the bad insights that happen because of that. So there's a couple different ways we can kind of attack these problems. And the first one is dashboard optimization. Okay, so when you think about sort of using Snowflake as your driver, you might enjoy bringing your data into Snowflake and then curating your different tables that you plan on serving BI dashboards on. But keep in mind that every time that you deliver a BI dashboard, there's some challenges that you need to overcome. So for example, you want to serve a dashboard that uses a lot of aggregate functions and group bys. So the problem is that these take a while for any query engine to do, because it has to kind of like load up the records, group the records into different groups, then run sort of calculations like averages, mins, max. And again, basically that's always going to take a second. So in that case, especially when you're doing really, really large data sets, that can take lots of seconds. So this results in PI dashboards that don't feel very fast and crisp. Okay, so oftentimes there's different solutions you can do with this. One solution is we can create a new table. Okay, what we do is we just use SQL and then create a new table that is just the results of the pre-aggregated data. And you can do this easily by using Snowflake's group by cube or group by rollup command to materialize a whole new table. Now, this comes with a couple different challenges. One, you're creating a new table. So this means this is a new namespace. So it's no longer table A, it might be table A ag. Now, the data analyst now needs to be aware that they should be using table A ag, not table A. And if not, they're going to result in like really slow dashboards. So there's this sort of learning curve. And when you're starting to do that with lots of data sets, that just kind of continues to add up. On top of that, that materialization may have to be rebuilt periodically. So you have to constantly make sure that you have a cadence where you go back and rerun those queries and rematerialize that table. So that way that table reflects sort of the newest data, which can again be an expensive process because you're redoing the entire calculation from scratch. Okay. But there are ways to kind of improve upon that. Okay. You could use Snowflake's dynamic tables. So Snowflake's dynamic tables allow you to basically define a table through a query. Okay, and basically what will happen is that every once in a while, Snowflake will then update that table based on the rerunning that query. Okay, and basically now you still end up creating a new namespace. So you're still creating a separate table. There's still a separate name that the analyst needs to know how to use, but it'll stay up to date. And there's going to be certain limitations that Snowflake has on this, such as like certain window functions you can't do and certain joins you can't do. So while this can be a solution for some use cases, it may not be a solution for all use cases. So what can we do there? And here's where Dremio can really help you out. Okay, what you can do is you can actually connect Dremio to your Snowflake account. And basically you'll be able to query all those tables right there through Dremio. But what you can do is you can create a reflection. Okay, so a reflection is very similar to that, kind of like that dynamic table, but with a couple differences. Okay, essentially what you're doing is you are defining, you are creating sort of a materialization of pre-computed results, so pre-computed aggregates in the case of an aggregation reflection, but it's not created under a new namespace. Since Dremio basically has its built-in semantic layer that allows it to track the relationship between different objects, it is aware that this reflection was created in connection to that data set, that Snowflake table. So now when a query comes in, so if you build the dashboard directly from Dremio, when that query gets sent to Dremio for that Snowflake table, Dremio is able to swap out the reflection. So instead of you having to know this other namespace, okay, you just use the same table name you've been using. So you can just actually create the dashboard directly on table A, and then based on the queries, Dremio will swap out the reflection. There is no limitation as far as like what kind of queries you can do. So, because again, it's just based purely on the result set. So basically you can use any type of window functions, aggregations, whatnot. There's not really any limitations there. And it can even be done on joins with data sets that are outside of Snowflake. So whether they're Iceberg tables on your data lake, tables that you have in MySQL or Postgres, whatever sort of like the data set that you want to reflect, you can just enable reflections on. So it gives you a lot of flexibility and allows you to take some of those edge cases out of your experience with your Snowflake tables without necessarily you having to move that table anywhere. Okay, so that's sort of one way. And then this actually will also help reduce your costs, because essentially what will happen is that you will reduce your overall compute costs to serve that dashboard with those aggregation reflections. And then also, in the cost of having to update those reflections as well. Okay, so basically this is what the resulting idea would look like. So essentially you would take your Snowflake table, connect it to Dremio, and then with Dremio, you can create a reflection. So you can kind of think of it as like Dremio's version of a cube, okay, with some, cool nuances, like not creating a new namespace, being sort of automatically updated for you and not really having any limitations. But basically Dremio will generate that for you. And then, so when you connect Tableau is going to direct those queries to Dremio, who will then push down to Snowflake, but Dremio will know to swap out intelligently for the right queries the reflection, speeding those queries up, and actually, again, reducing the overall cost of like egress, things like that. Cool. Second problem, you might have data unification issues. So the idea here is that you have your data in Snowflake. You like having your data in Snowflake. You get data from the data marketplace, all sorts of great things, okay? But you have data elsewhere. You may have data in Postgres databases, Mongo databases. You might have data in other data warehouses, on your data lake. And typically the solution would just end up being you have to go basically move that data into Snowflake. So you have to kind of create all these ETL jobs to get that data in there. And that's fine. But again, there's storage costs and again, brittle ETL pipelines that have to be created that can result in backfilling and other types of issues that delay things versus just using the data where it's at. Okay. So once again, you can connect your Snowflake account and any other sources over to Dremio. And then from Dremio, you can then unify those sources. So you can join your Snowflake table with that Postgres table, join that Snowflake table to, a table that's in Redshift, join it with a table that is in Synapse or whatnot. You'll be able to kind of combine that data without having to move that data. Okay. And then now, of course, here's the thing. If you're connecting multiple clouds, so basically we run into this issue of what's called egress cost because, hey, you might be, when you move data out of a cloud, it results in an egress fee. So when you move the data out of Snowflake, there's egress fees. When you move data out of, let's say, Redshift, out of AWS, there's a egress fee. So how do you minimize that? Well, this is another place where reflections can come in. You can turn on reflections. In this case, probably a raw reflection where it actually creates a copy of rows and columns, okay, on those data sets. So what you could do is if you're going to join Postgres and a Snowflake table, or let's say you're going to join a Redshift and a Snowflake table, and you're going to create a dashboard off of that or create reports off of that, what you can do is you create the join, then turn on reflections on the join. So that way Dremio basically creates that materialization of the result of the join. So now going forward, every time a report that's fed off that join or a dashboard that's fed off that join isn't going to result in more egress costs because it's not continuously pulling the data from a Redshift and Snowflake. Instead, it's using that materialization to serve up the dashboard, which will not be subject to egress costs because it'll exist within the same cloud that your Dremio instance is running in. Okay, resulting in, again, not only having that data unification, but also reducing, again, egress costs and achieving that. So that's another solution you can use when you basically pair Snowflake and Dremio. So this would look something like this, where you have Dremio as sort of this unification layer between like the different clouds, databases, data warehouses, essentially everything kind of connected to Dremio, allowing you to federate that. But it's the reflections feature that really allows you to minimize the cost in doing that. Because one thing is to make it easy to unify, another thing is to also do it and not end up escalating your costs and be able to do it performantly at scale. And Dremio is going to have the feature sets to do all three. Next, simplifying ingestion. Another problem you may have is you may have lots of different data sets that you want to put into Snowflake. Okay, so maybe you may have data in Postgres, you might have data in Mongo, you may have data in ADLS, you might have data in S3. And normally what you'd have to create separate pipelines to kind of put all of this data into Snowflake. And what you can do is instead of that, you can connect all, and then basically then you do your modeling in Snowflake, which is fine. What you can do is you can actually connect all of these data sources in Dremio, basically do your modeling virtually in Dremio. Okay, so basically you'll have all the data sets pre-joined, clean, modeled out, and then essentially what you do is you ETL those final, those final sort of gold versions of the data that are already pre-modeled, so that way you're only moving the data once and you're moving the data only from one place. So essentially it's just one script that basically runs a query against that modeled data set in Dremio and then makes a copy of it in Snowflake, making the sort of the whole process and the cost of doing that ETL over to Snowflake much, much more affordable. Because again, also if you're taking advantage of reflections along the way, you can minimize the egress costs of unifying all these data sets, which is also going to, and then so you're going to minimize your compute costs in ETL, you're going to minimize your egress costs, but it's also going to simplify and make the whole process easier because again, you can pre-model the data in Dremio, and then you're just delivering that sort of final row of data sets. Okay, so again, what you're seeing here is that you have your application. Your application is feeding data into Postgres and Mongo. Some of that data is maybe landing in the data lake. but all of these are connected to Dremio, and using Dremio, you can then deliver that data to Snowflake pretty easily. Again, you would just basically write a Python script that basically sends over a query to Dremio, takes the result of that query, sends it over to Snowflake. Pretty straightforward. Basically, the way I would do it is I would go query Dremio, load the data up into like a pandas or polars data frame, and then go take that data frame and then load it up into Snowflake. Okay. And then there's another possible, and this is going to be more future looking because basically the feature sets that are needed for this solution are being developed by both Snowflake and Dremio, but they're not fully there yet to quite get to the effect, but they will be. And this is what you can see happening in the future. The idea of just having sort of one copy of your data and being able to use the different tools that you need as you need them. And this is all powered by the power of Apache Iceberg. So the idea is that your data would just be in Apache Iceberg tables. So they're not going to be in Dremio. They're not going to be in Snowflake. They would be on your data lake as Apache Iceberg tables. People are already doing this with Snowflake and Dremio using Apache Iceberg tables. But the challenge is always right now is the story of a catalog. Okay, because basically right now there isn't really all catalogs aren't basically set up to talk to every tool. So you may have Apache Iceberg tables, but they may be tracked by a catalog that may not be able to talk to X tool or Y tool. Okay, so currently Snowflake catalog can only be read and written to via Snowflake and only can be externally read to by Spark. Okay, with the Snowflake SDK. Then there's Nessie catalog, which is what powers Dremio's internal catalog in Dremio Cloud. And that can be talked to by, Dremio, by Trino, by Presto, by Apache Spark, by Apache Flink, but not yet by Snowflake as an external catalog. Okay, so basically right now, there's just this sort of disparity between sort of being able to talk to the Iceberg tables here and the Iceberg tables there. But there is a new universal protocol called the Apache Iceberg REST catalog spec. Okay, and eventually Snowflake catalog will be adopting that Apache Iceberg REST catalog spec, and Nessie has already announced that it's adopting that Apache Iceberg REST catalog spec. And again, this is just known because basically every catalog is moving in that direction. In the future, this will be the universal way that all tools connect to. So essentially, once that is all implemented, Dremio will be able to connect to Nessie catalogs, Dremio catalogs that are already built in, and Snowflake catalogs, and be able to query those tables and possibly read and write to those tables. And Snowflake will be able to connect to Snowflake's catalog, and then use through its external table feature, be able to connect to your Dremio catalog, your Nessie catalog, to be able to read and write to those tables. So this means you'll be able to basically minimize your storage costs because you're not storing multiple copies of your data. You just have one single source of truth, but you're able to take advantage of the features of both tools. Okay, so you're able to take advantage of reflections when you need reflections. You're able to take advantage of dynamic tables when you want to take advantage of dynamic tables, depending on your particular use case, in particular, what are you trying to build. Be able to use Snowpark for AI and ML, but be able to use like Dremio to fuel dashboards again with those aggregate reflections. Basically, you can decide sort of what you need for your use case because everything can just be used anywhere because you have your data in a universal format, and then basically all tools can talk to your catalog that's tracking those tables. And that's sort of the future that Apache Iceberg is going to present to how you can use Snowflake and Dremio together. So that kind of sums up a lot of the ways that Dremio and Iceberg kind of fit together in a really nice package. And you can kind of hear more about this by joining us at the Dremio and Snowflake event, Iceberg-centric analytics and AI. So again, this is just an event that Dremio is holding nearby the Snowflake Summit, which is going to be at the Dremio Chill Lounge at 221 4th Street, San Francisco, California 94103. Be there, come hang out. I'll be there all day, 9 to 5:30 p.m. And again, check out a new article we did talking about sort of like the data sharing story with Dremio and other clouds. So you can kind of scan this QR code to go read that article. We have lots of other great new articles over there at thedremio.com/blog. And again, if you want to get hands-on with Dremio, so you can see a lot of the things I was talking about sort of hands-on, scan that QR code to the left and you can set up Dremio on your laptop using pretty easily with Docker and actually get hands-on and experience, what is this thing that people are talking about. And again, those other exercises, if you want to go end-to-end, experience taking data from a Postgres table, loading it to your data lake as an Apache Iceberg table, then feeding it in Apache Superset dashboard, or do the same thing with SQL Server or Mongo. And there's actually even more iterations of this exercise. on the Dremio blog using MySQL, using Apache Druid, using JSON and CSV files. So that way you can kind of find the exercise that fits you best.